Hey coach, how's it going? Hey Ben, whoa, looks like you put on some pounds since the last competition, huh? What do you mean? I swear I've only been eating kale chips and broccoli for weeks now. I'll make weight, don't worry. Alright, champ. Anyway, from now on, I want you to use this new app to track your diet and exercise every day. And we can use big data and AI to compute the best training plan just for you. Coach, that seems like a lot of work, man. Aren't you at Olympia this year? Now give me 50 push-ups.
Welcome to this first video in our Data Science for Sports and Fitness video series. Today we will cover PMData, a dataset containing dietary, exercise, and many other life logging parameters. And no matter if you're like Ben's overly ambitious coach or a data scientist looking for the next resume project, I'm sure that this video will be very valuable for you. PMData was created in an effort to bring a more comprehensive and standardized way of tracking data to the sports and life logging community. Essentially, the goal of the authors was to track both objective data, like for example from a smartwatch, as well as subjective information like in surveys. And overall, the goal was also to run a challenge, with the aim of the challenge being to predict whether the participants would gain or lose weight and what their running performance would be following these 5 months of logging and training. At the start of the study, the authors created a baseline overview table that contains socio-demographic features, whether the person considered themselves to have a type A or type B personality type, their maximum heart rate, their 5-kilometer run performance on their first run, and their stride length during walking and running. Participants were also instructed to take pictures of their meals and beverages every day, to log sport-related factors like injuries, training load, and wellness in the PMSys sports logging application when prompted by a push notification, and to answer a daily Google Forms survey about the number of meals they consumed, the current weight, and the fluid as well as alcohol intake. Lastly, participants were asked to wear the Fitbit Versa 2 smartwatch as much as possible, even during sleep. We'll cover the details of the smartwatch recording in the next chapter, but generally, data on the sleep quality and specific sleep behavior of a participant, various heart rate measurements, data on different activity levels like sitting, walking, or very active activity, very specific exercise data, as well as common smartwatch variables like calories, steps, and distance walk can be recorded using the smartwatch. In total, there are 16 folders in PMData, one for each participant. In the root directory, there's also the baseline overview file, which indicates that 13 participants were male and 3 female. Inside each folder, subdirectories for each of the just mentioned data components are located that in turn contain their respective data files. Now let's look how often each variable was recorded. We noticed that some of the smartwatch biosignals, like heart rate, have a much higher rate of entries than other variables. As we can see, surveys were supposed to be answered mostly on a daily basis, and in some cases, like with injuries, even just once a week. So feel free to pause the video to further familiarize yourself with each variable. Smartwatches capture movement using an accelerometer and the heart rate using a sensor that shines light into the skin, something known as PPG. The watch calculates the heart rate by counting the peaks of the signal per minute, and the heart rate variability, which indicates how much the time between beats changes. The heart rate variability can then be used, for example, to monitor sleep cycles. Using these signals, the watch computes the duration of a user's sleep, the sleep quality, and restoration, where sleep quality is determined by how much time subjects spend in deep and REM sleep, and where restoration is respectively determined by how relaxed someone was during sleep, essentially how little they moved. Final sleep score, which can be found in the file with the same name, is generated that combines these values. For most healthy adults, it lies between 70 and 80, but can reach up to 100. General sleep file overall tracks how much sleep was spent awake and in light, deep, or REM sleep. The Fitbit Versa 2 can also use context recognition to auto-detect workouts and to classify activities as sedentary, light, moderate, and very active. When a workout is tracked, attributes that are available for the entire day are again stored for that specific workout, like these just mentioned activity levels, heart rate parameters, steps, calories, etc. A special note on heart rate zones. Fitbit tracks the 4 zones out of range, fat burn, cardio, and peak in increasing order of intensity, where the interval of each zone is adapted to the fitness level of the user. In the file time and heart rate zones.json, which tracks them for the entire day, they are referred to as default zones. Now that we covered all of the biosignals, let's quickly explore the PMSys sports logging app. Injuries are tracked by clicking on the respective body part. For each training session, the participants rated their perceived exertion of a workout from 1 to 10 and saved the duration. The training load, or SRPE, which stands for Session Rating of Perceived Exertion, can then be calculated as the product of the two. Wellness is tracked with several parameters like fatigue, mood, readiness to train, sleep duration, sleep quality, soreness, and stress. Here I've created an overview of how many recording days were available. Green marks when everything was filled out as intended by the study authors and that there is data available for each of the 150 intended study days. Yellow shows when more than 70% were available, and red that no records were available, with orange showing everything in between. We noticed that only 3 participants actually took food pictures, which the authors explain by the fact that it is a very time-consuming activity. The PMSys fields were in general filled out less often, while some Google Form entries were more frequently filled out than others. Participants, for example, did not weigh themselves for the entire length of the study, and smartwatch parameters were, however, recorded with higher consistency, with most participants wearing the smartwatch every day. The exercise recordings being less commonly filled is easily explained by some participants exercising more often compared to others. Of course, dataset quality can be measured in a large variety of aspects like accuracy, completeness, validity, consistency, and many more. Without going too deep into details, we can state that one of the issues with PMData and live logging studies in general is that participants started logging entries with high consistency at the start of the study, but the rate of entries tapered off in the last 2 months. In terms of outliers and suspicious values, however, the authors did a great job. No outliers could be found in the subjective parameters, and only very few biometric samples, like a heart rate value being negative, for example, in 1 in 100,000 samples, could be found. Another point worth critiquing is the gender imbalance, with only 3 women compared to 13 men, which depending on the task can turn into a problem in medical data science applications. This goes along with the overall number of participants, which could be improved in follow-up studies.
A large variety of machine learning applications can be envisioned around PMData. The authors of the paper originally started with a seemingly simple prediction problem, which consisted in predicting the weight gain or loss on the following day. Google Docs, the PMSys wellness reporting, and the Fitbit sleep scores were used as input features, and classic machine learning algorithms like random forest and decision trees were applied. Now, the results were not amazing, but groundwork was done that proved that other data scientists could build upon this first experiment. So some other functional applications include predicting a fighter's weight gain or loss for the next competition, like in our initial introduction, predicting a person's readiness to train for creating the optimal training schedule, team management and performance measurement for large teams of athletes. And naturally, one could also think about more fundamental scientific projects like developing data fusion approaches. To quickly recap, we introduced PMData, a dataset created to show how live logging and sports tracking could be combined in a standardized and comprehensive way. We explored all subjective and objective parameters involved, dove into variables for live logging and explored the PMSys app, critically investigated the quality of PMData,
and mention some applications that could get you started on your next project. With this, I hope that you can now decide whether this dataset is something you would like to get your hands on. So thank you for watching and happy hacking.